Hi, I'm making this video to share my experience building an electric skateboard. This is actually the first electric skateboard I ever built, and I did a lot of research online. I went to electric skateboard builders and other websites and looked to see what parts are available and really tried to find what would meet my goals for this skateboard, which are different than what most of the electric skateboards on the market are. So here were my goals for this project. First, I wanted it to have a kicktail. I also wanted it to be reasonably small. I didn't want to feel like I'm standing on a small electric car. I wanted something that resembled a skateboard and has a ride height like a skateboard. Another thing is I wanted it to be reasonably light, maybe around 10 pounds. I wanted interchangeable batteries. I wanted a good range, maybe around 10 miles per charge. I wanted it to be able to get up most hills. I wanted it to have a good top speed, at least 15 miles an hour. I wanted it to be affordable. I was shooting for around $500. I was a bit flexible because I wanted good components. Another thing is I wanted it to be easy to build. I didn't want any custom-made parts or things that would be very time-consuming. I wanted something most people could probably build at home. And that's it. That's pretty much my main goals for the project. In most places I think it met those goals. In some places it maybe fell a little short, and in other places it did better.
After searching for hub motors on eBay, Alibaba, and other sites, I decided on the 70mm motors by Maytech. Almost all hub motors are 83 or 90mm, which is very large compared to non-electric skateboard wheels. I wanted to get as close as I can to a standard shortboard wheel size, like these 53mm wheels. The Maytech motors were pretty much the only decent option for a smaller wheel size. I ordered these as a set along with the front wheels and trucks. Altogether it ended up costing around $266, which also included express shipping.
Other than the size, I also wanted a motor that could handle up to 36 volts. Some of the cheaper motors I saw only say 24 volts in the specs, although I'm guessing you might be able to run them a bit higher in reality.
The main reason I went with hub motors instead of satellite motors with belts is the smaller size and simplicity of the hub motors. For a shortboard, it would have been difficult getting the motors and belts to fit and still have enough clearance.
After running these for a few weeks, I definitely noticed some pros and cons. The pros are that they're lightweight. I weighed them at about 585 grams, which is pretty light compared to the larger hub motors. This 83mm wheel weighs in at about 746 grams. Another pro for me was the lower ride height I got with the 70mm wheels. That's something I really wanted for this build. Also, the connectors on the hub motors are pretty good. They're well made and easily plug into the connectors on the ESC. Another thing is the trucks, motors, and front wheels all match and were easy to put together. The cons are is that they might not be very durable. After a few rides, some of the screws fell out of the wheels. As you can see here, 3 of the screws are missing. I got some new M3 screws and re-screwed everything in with thread lockers, so hopefully they'll stay in now. Another con is they get pretty hot when you push them, especially up hills. That's probably a side effect of them being smaller and having less metal and less surface area to dissipate heat. Another thing is they don't have the power and top speed of larger motors. That's probably another side effect of them being smaller. But the smaller size does help with the acceleration and torque. Overall, I think these motors aren't bad, but might not have been the best fit for some of the other goals of this project. I'd recommend these for a light board to use for shorter commutes that are relatively flat and lower speed. The lightweight and low ride height are definitely the big selling point. If you're looking for a faster, more powerful board, then I'd recommend larger motors. When researching parts, I quickly saw that the VESC or VESC is the one that most electric skateboard builders really like. I bought mine from Maytech, which is the same company I got the hub motors from. These are the 2 VESCs that power the motors. One of them is the master, which I've labeled M, and the other is the slave. And this is the CAN bus that connects them to each other. I did look for other options at first, because the VESCs can be a bit expensive. They're around $100 to $120 each, and that can add up because 2 hub motors needs 2 ESCs. The biggest thing that prevented me from using other options like an RC car ESC is that I wanted an 8S system, and that's around 33 to 27 volts when fully charged to fully discharged. And almost all mass market RC components end at 6S, which maxes out at about 25 volts. Good thing about VESCs is that they're designed specifically for electric skateboards, and they're very configurable and support all the way up to 60 volts. Configuring them can seem a bit scary at first, but it's really not that bad, and there are many videos on YouTube that show how to do it step by step. One unusual thing I noticed is that when I use the BLDC tool that connects to the VESC to detect the motor values, it doesn't seem to detect them correctly when the motor is just stopped. And when I was riding the board, it wouldn't start correctly from a standing stop. The detection seems to work a lot better if I pre-spin the wheel right before doing the detection, kind of like this. After doing that, it worked a lot better. And I don't know if it's something just with these motors, but at least with these, that made a big difference. I first thought to use electronics cases like this one, but that turned out to be a pain because they usually need screws to open and close. Food containers come in many shapes and sizes and are easy to find. I also like that they're see-through and you can make sure that everything's hooked up correctly and turned on. This is actually a sandwich container I got from Target. It worked out well because it's thin and the right size for the board. It's also easy to open and close, and I've never had a problem with it opening on me while I was riding. To attach the container to the board, I used these 3/8 inch screws. They hold pretty well. I could maybe put some washers to make it a little more secure, but it's been alright. To get the cables from the motors to the ESC through the case, I drilled 2 1/2-inch holes and then cleared it out with a razor blade. For the battery cable in the front, I cut this notch. That way the cable can go underneath and the lid can close on top. So before attaching the container to the board, I cut some of the lip on the bottom that you can maybe see here. Because the board's concave, I cut the center parts and left only the edges where the handles are. That way it really sits on the board better. So here's how I put them on the board. It's a bit messy, but it's been working well enough. I used Velcro ties to keep the 2 VESCs together, and then some more Velcro to hold all the wires together. I used this anti-spark connector to power the system, and it's definitely important to use one of these because you will get a big spark if you don't. So as I was saying before, this build uses 8S batteries. And as I also mentioned, RC components almost never exceed 6S. So I'm using 2 4S batteries with a series connector here. I taped up the series connector just to keep everything together. When looking for batteries, I needed ones that were flat enough and hopefully lightweight. The obvious trade-off with size is the weight and capacity. I wanted a good range, so I went with these 6.6 amp hour batteries. These might be a bit overkill for most rides. For lighter weight builds, I'd go with maybe 4.5 to 5.2 amp hours. For the battery pack, I used another food container. This is one of those sort of disposable types. I had to cut the corners a bit to get the batteries to fit well, but it works pretty well. I used adhesive Velcro to attach the battery to the container. So to secure the battery to the board, I use these metal brackets. I screw the brackets to the board and then I run the straps underneath the brackets. This works a lot better. I originally ran the screws through the Velcro straps themselves, but the battery's pretty heavy and it actually caused the screws to rip through the Velcro straps. So here's what happened to the front strap. It ripped completely on this side, and this side is almost ripped. It probably didn't have much longer. So this does a much better job at holding it. And now I can just put the battery pack on, and I also used adhesive Velcro here to make sure that the straps don't move around. And now I can just strap the pack to the board and it stays put pretty well. So to charge the batteries, I use this parallel charging board so that way I can charge them at the same time. You can find videos on YouTube, a lot of them, that will show you how to charge LiPo batteries with parallel boards and stuff like that. The only thing is that I would be very careful of is one of the drawbacks of using the parallel boards is this actually happened to me once where I hooked up these balanced charge cables and then I went to hook up the other one and I accidentally had the cable reversed. It won't let you actually plug it in, but I just touched some wires and there were just like sparks everywhere, wires melted, and I had to throw this away and I had to redo all the pins and it was a big mess. So you want to be really careful, and that's, I guess, one of the things when you have 2 battery packs that you got to be careful about something like that. If you hook them up directly to the charger, I'm pretty sure the charger will protect against that. I haven't tried it and I wouldn't really want to try it, but I'm pretty sure this thing has protection for that kind of stuff, where when you use one of these boards it's a little bit more risky. So in general, having one battery is definitely easier. So to charge the batteries, you just hook up all the power cables. I think you can do it in any order. Just make sure you get these balance charge cables in the right direction. Then I have to make sure my charger is set to 4S, which it is. It'll actually check that it's 4S. And now I can see the voltage per cell as it's charging. And this is almost a fully charged battery. So to make it easier, I made these extension cables. And this is actually an extension and a converter, because it's an XT90 to an XT60. And this system works pretty well to charge it. It's definitely easier to have just one battery, but with this board it's not too bad. You just have to be careful. For the remote control, I went with this small controller made by a company called Winning. The main reason I got it is it's small and has a decent design. It's easy to hold and use the accelerator and brake. The not so good parts is the build quality could be better, and it was a bit too expensive in my opinion. Like with most components that are specially made for electric skateboards, there is a bit of a premium. Including shipping, I paid about $60 for this. As far as the build quality, if I zoom in a bit, you can see that the plastic housing was not manufactured very well. There's a pretty big gap along the back of it, especially around the switch and the controller part. I sent an email to the company I bought it from, and they told me that that was normal and it's the way it's supposed to be, so I guess that's the way it's supposed to be. It has worked well so far though. I haven't had any issues with it disconnecting from the board. It also has a switch for the second channel on the back. This could be useful for something like LED lights or anything else you want to control from the remote. This controller should work with any ESC. However, if you're using the VESC, another option is the wireless Wii nunchuck controller. I obviously haven't used this yet, but there are instructions online and videos and it seems pretty straightforward. This should work with any ESC, so I might use it for another build in the future. So for the deck, I wanted a regular skateboard style deck with a kicktail. I bought this from a place called skateshred.com for about $20 including the grip tape. I originally tried this 27-inch board, but it was way too small and looked kind of ridiculous with the 10-inch longboard trucks on it. So instead, I went with the 30-inch board that has the same shape, but it's 30 inches by 8.75, and that worked a lot better for me. The good thing about building your own electric skateboard is that you can use any deck that you like. If you want a shorter board or a longer board, or one with a different shape, you can get whatever you want. Now for the fun part, testing the board.
With the battery, the board weighs in at about 12.2 pounds. The battery by itself weighs about 2.6 pounds, which means the board's about 9.6 pounds without the battery, which is pretty good for a dual motor setup. So here you can see the size compared to other skateboards. On the right is a standard popsicle stick style skateboard, which is 32 inches, and on the left is a 27-inch penny board. So here I lined up the back wheels so you can see the wheelbase of the different decks. Some have shorter noses so you have more room for electronics and batteries out of a smaller deck. In this case I didn't really need that extra room, so I really like this one, but for another build I used a deck with a shorter nose.
You know, it's kind of hard to see with the camera. I think from what I can tell, it's about
half an inch. The electric skateboard's about half an inch higher than my standard skateboard in terms of the ride height. You kind of get a better idea, maybe with some angles here. So this is the westbound direction of my speed test road. It's pretty flat. It's hard to tell if it slightly slopes. I can't tell. It actually looks pretty flat, and that's why, to be sure, I've tested in both directions. So this is the same street facing east now, and it looks like it could be slightly uphill in this direction, but I went in both directions when I tested speed just to make sure it's fair. So as far as the roughness on the street, it's pretty good. It's pretty smooth, not like the concrete on a skate park or something like that, but it's not much resistance. Board rolls pretty good. Here I'm at the bottom of the steeper hill. It's pretty steep. Not crazy steep, but kind of steep. And here it's kind of flat, to give you an idea. And if I try to hold the camera pretty much vertically, maybe that can give some idea. But it's hard to tell from the camera. But especially part of the hill gets really steep. It's not that high of a hill, but it does get pretty steep at its steepest point. So I just went up these two sets of hills. The first part was pretty steep, and then the second part was less steep, and you can see the speed on the two different parts. Here I'm just coasting. Using a little brake. Don't want to get hit by some cars here. Gotta look around. Alright, now I'm gonna go down the steeper part. Gonna use the brake. Not going too fast. Still feel safe. So I just fully charged the battery, and I'm going to take it on a range test now to see how it holds up. Might not go all the way until the battery runs out completely, but at least go a pretty good distance just to see what the voltage is at the end and see how much of a drop there is. So we'll see. Part of the way is on some rough sidewalk. I'm going to switch over to the path, like there's a bike path on the street. So now I'm on the bike path on the street, so I can maybe go a little faster. Still not going full speed most of the way. On and off I am. I guess I'm still getting used to it. Getting closer to the beach. I think I'm going to switch to the sidewalk. This is some rough pavement. Here's Venice. Hey, some people waving. So that's the Venice skate park. And here is where I usually go surfing. There's actually a few surfers out there now. It's so windy though. So now I'm at the Venice skate park. It was about 3 miles to get here. I'm probably gonna go a little farther down the bike path and then head back towards my place. There's sand here. I hope it doesn't mess up the hub motors. Got stuck in the sand. in that building. It's a bit of an uphill now. Things still moving fast. I think I'm probably going around 15 miles an hour. Noticed one of the Velcro straps broke. Gonna have to be really careful now. Wow, someone did a big donut here. So I'm just getting back from a 6.5 mile ride. It did well. The battery needs to be secured better, but it went through different terrain. I went through some sand, I went through some bumpy pavement, some bumpy sidewalks. So here we can see that one of the straps broke and the other one held on. It didn't fall out because this is also connected to this holder with adhesive. So it still held together enough for me to get home, but I have to at least add another strap around here. So now I'm back. I got the battery hooked up to the charger, and see if I can see how much the voltage is. 15.15. It's about 3.78 per cell. So it's not too bad. Oh, that was like a 6.5 mile ride. Getting back from 8 point something, a little over 8 mile ride.
That's awesome.
Let's see what the battery looks like. About 3.75 volts per cell. That's pretty good.
Now let's see how I did with the goals. Let's see how I did on price. After building and riding this board for a while, I definitely learned some lessons. In my attempt to make things easy, I did manage to avoid creating a custom mold for the electronics or making my own battery pack. However, there was more soldering than I would have wanted, although it's not too difficult and you could find many great videos on YouTube about it. Also, using two batteries is a bit more complicated than it would have been with just a single battery pack. An important thing I learned is that rather than try to build a single board to do everything, it's better to think about what I'm going to use the board for and then build something that suits that use. So if I'm going on long rides up steep hills at higher speeds, I'll make different design choices than if I want something portable for lower speed hops between nearby places. Because if you have to carry a board very much, you'll really be hurting if you have big heavy motors and batteries. While researching this build, I found some other good deals and bought some extra parts to experiment with. I've built another board since this one and I plan on building another. I'll try to post some videos to share my builds and what I've learned in the process. I should be getting the Act and Blink S2 soon, maybe even before I get to post this video. I was one of the early contributors in early November and have been waiting a while. I actually built this board because I didn't want to wait any longer. But now that I've built some other boards, it'll be interesting to see how the S2 compares. I'll try to post a review of the S2 also. I hope this video is useful to anyone thinking to buy an electric skateboard. One thing I can say for sure is they're super fun to ride, and I'm glad I built one. Thanks for watching.